Hi, welcome to another session of Ebenezer Gate coaching classes. This is a question that appeared in Gate 2025. It's a numerical aptitude question carrying 2 marks. A 50 ohm lossless transmission line is terminated with a load ZL of 50 minus J75. If the average incident power on the line is 10 milliwatt, then the average power delivered to the load rounded off to 1 decimal place is dash. Now in transmission line, we know that the reflection coefficient, which is the magnitude of the reflected signal divided by the incident signal, gamma is given by ZL, which is a load impedance, minus the characteristic impedance divided by ZL plus ZL. Now ZL is 50 minus J75 ohms and Z0 is 50 ohms. So the reflection coefficient is 50 minus J75 minus 50 divided by 50 minus J75 plus 50. So this is actually minus J75 by 100 minus J75. So if you divide the numerator and denominator by 25, you get minus J3 by 4 plus minus J3. So if you take the magnitude of the reflection coefficient, you have 3 divided by root of 4 square plus 3 square, that is 5. So it is 0.6. So the magnitude of reflection coefficient is 0.6. So the magnitude of the power of the reflected signal is actually the magnitude squared of reflection coefficient times the incident power. Incident power is given as 10 milliwatt and the reflection coefficient is 0.6, so 0.6 whole squared into 10 milliwatt. So this is 0.36 into 10, that is 3.6 milliwatt. Now the power transferred to the load or the transmitted power is power transferred to the load is actually P incident minus P reflected. So it is actually 10 milliwatt minus 3.6 milliwatt, which is 6.4 milliwatt. So the answer to the question is 6.4. So the answer is in milliwatt, so it is 6.4. Thank you. God bless you.